Well, okay, so today we're going to go over question number 4. We have a plant that has a transfer function P of S equals 1 over S plus 1 over S plus 4. Then a compensator such that the closed loop system has a pair of complex poles. Damping ratio is 0.5. Natural frequency is 2s to the negative 1. Alright, fine. Simple question. What is it really asking us to do? Let's just take a step back and just intuitively understand what we're being asked, okay? We're being asked to make a system such that the entire system is pair of complex poles, the system's pair of complex poles, the poles of our entire system must satisfy this criteria. So step 1 is to ask what are the required poles. Well, I'm told that P of S is equal to 1 over S plus 1 over S plus 4, so I have this as a second order system. The plant is second order, which means that it obeys the omega n squared over S squared plus 2 zeta omega n S plus omega n squared. Plug in your numbers, you get 4 over S squared plus 2, 1 half, 2S plus 4, 4 over S squared plus 2S plus 4. Or 4 times 1 over S squared plus 2S plus 4. And then you ask, okay, so what are the poles of S squared plus 2S plus 4? X is equal to negative b plus or minus the square root b squared minus 4c divided by 2a, 1, 2, 4. You end up with we can do it in our calculator if we're not being stupid, and we get S is equal to minus 1 plus minus root 3j. These are the final poles that I want to end up with. This is my desired system. This is the desired stuff. Alright, part 2. How do I get there? There's a rule. The rule must be obeyed. The rule is that the sum of the angles contributed by the C of S plus the sum of the angles contributed by the plants, so the controller and the plant's contribution, angle contributions. We'll explain what angle contributions mean in a second. But the sum of the angle contributions must equal to minus 180 degrees. This is a rule. I don't know where it came from. I don't care where it came from. It's just a rule that I obey. Now, the sum of the angles of something is the sum of the poles minus the sum of its zeros. Fair? Okay, done. Now, 3 is to ask myself, well, what is the... I don't know what the compensator is, so trying to find this right now is useless. But I know what minus 180 is. It's minus 180. And can I know what the angle contribution of P of S is? Well, yes, the angle contribution of PS at the desired pole is going to be, well, what's P of S? P of S is 1 over S squared plus 5S plus... Okay, let me actually do this because I don't know. It's 1 over S squared plus 5S plus 4. 1 over S squared plus 4S plus 1S plus 4, so 5 and 4, yeah. 1 over S squared plus 5S plus 4, okay. So 1 over S squared plus 5S plus 4, where S equals SD, which is equal to minus 1 plus minus root 3j. Doesn't matter, you can pick any of the conjugates, but just pick the positive because we want to work in the easier plane. Okay, and then you plug this in your calculator in phasor format, and what do you get? You get, let's put it in complex poles, and let's do it in phasor format. And let's say that minus 1 plus root 3 of eng is going to be stored as a variable, and 1 over x squared plus 5x plus 4, and I get 1 over 6 with a phase of minus 120 degrees, which means that PSD equals this, which means that the phase contributed by PSD is equal to minus 120 degrees. Now, you don't need to do this because like no one cares, and on the exam you have access to your calculator, but if we just wanted to do a very, 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 very quick sanity check to do this, we can see that SD is equal to minus 1 plus root 3j, and SD squared is equal to a squared plus 2ab plus b squared, which is going to be 1 minus 2 root 3j plus, minus 3. 1 minus 3 is minus 2, so it's going to be minus 2 root 3j. This is sd squared, and my entire row is sd squared plus 5sd plus 4. So it's going to be, it's going to be minus 2 root 3j plus 5 of sd, which is minus 1 plus root 3j plus 4. 4 minus 2 is 2. And 5 times minus 1 is minus 5. And 5 plus 5 root 3j. And minus 5 plus 2 is minus 3. And 5 root 3 minus 2 root 3 is 3 root 3. And so I end up with minus 3 plus 3 root 3j as my guy. And I can see that minus 3 plus 3 root 3, j makes an angle of, well, here's minus 3, here's 3 root 3, and the angle that I'm looking for is going to be 180 minus theta equals something, because I'm looking for this angle, where that something is, 1 minus theta equals, 180 minus theta equals something, and equals the answer that I'm looking for. And theta here, at tan theta is equal to opposite, 3 root 3 over adjacent, which is 3. And that would be arctan of root 3, and arctan of root 3 is 60. So theta equals to 60 degrees. So 180 minus 60 is 120, which means that this angle is 120 degrees, right? So the angle formed by the denominator, s squared plus 5sd plus 4, is 120 degrees, but the angle formed by PSD is the angle formed by the 1 over the angle formed by the denominator, or 120 degrees, which means it's equal to the angle formed by the 1 minus 120 degrees, and the angle formed by the 1, well, 0. There's no angle. So it's 0 minus 120 degrees, so it's minus 120 degrees. And so we can see that my calculator is indeed goated, and it's at the right answer of minus 120 degrees. But please don't do any of this on the exam, because you're wasting your time. Now that we've made sure that the angle contributed by PSD is equal to minus 120 degrees, we can say that, well, the angle of if we can resume from this step. So for the angle contribution by C of S is going to be equal to minus 180 minus 120, which is equal to minus 60 degrees. And this leads us to part 5. Well, we said the angle of CS is equal to CP minus CZ, which means that the minus 60 equals CP minus CZ, which means that 60 equals CZ minus CP. So the angle contributed by my 0 must be greater than the angle contributed by my poles. Then I do a bit of graphing and I say, okay, so I'm going to go ahead and I'm going to do something over here. I know that my desired final row is minus 1 plus root 3j, which is going to be somewhere over here. And I know that, yeah, this is my desired row. Now, a lead and lag compensator, let's just we'll take an aside for now. Okay, we stopped here. 60 equals CZ minus CP. We stopped here. A lead compensator is one where the poles lead the zeros, right? You read left to right, so here's the pole, here's the 0, and this is a lead compensator. And if you think about this is your SD, this is the angle contribution of your poles, and this is the angle contribution of your zeros. And so you can always see in a lead compensator, the angles contributed by the poles are minus the angle contributed by the angle contributed by the zeros is greater than the angle contribution by the poles in a lead compensator. If you go to a lag compensator really quickly, we see that the poles lag behind the zeros. So the zeros are here and the poles are here, and this is your SD, and your poles lag behind the zeros imply what they imply. This is your pole, this is your zero. No, sorry. This is your pole and this is your zero. And so the angle contributed by the poles are greater than the angle contributed by the zeros. Okay. Right now, my SD lies on a -1 real axis and root 3j of height. And I am aware that I need the angle contributed by my zeros to be greater than the angle contributed by poles. I need a positive number. I need a positive difference, right? I need zeros to be greater than poles, angle contribution of zeros to be greater than angle contribution of poles, which is to say that I need a lead compensator in this case. Cool. And so I figured out the type of compensator that I'm going to need to design. It's a lead like all of the work we did previously was just setup, like pure secretary work to find what the system requires, and now we're actually designing the system and designing the controller, the compensator. And since this is a lead and this is a lag, and we know that we need a lead compensator with a zero, I know I'm going to have something of the format of this. And this will be my zero, this will be my pole. The angle contributed to by my zero is going to be something, the angle contributed to my pole is going to be something. And I know that z minus p must equal to 60. So how do I kind of translate that here? Well, you can think about it like one, one, two, three, right? And 1, 2, 3. And so like geometry class, you know, this bro is going to be this bro pole, and this guy is going to be this guy is the zero, and that means that this angle is z minus p, and it has to be 60 degrees. So in effect, I'm designing anything, any two zeros and poles, where the triangle that I make here is 60 degrees, and this falls on my zero, and this I call my pole, will satisfy the system, right? And it is easiest if the angle that you're required to design is less than 90, then it is easiest to just, given that your SD is you already have information about your SD, you could just say, I would choose to make it a right angle, because right angles are just really cute and easy to work with, right? And so you can just make this your 60 degrees, and make this your zero, and make this your pole, and call it a day, right? Everything works. Any triangle where the z minus p, we have agreed, the only condition I have is that the z minus the p has to equal to 60 degrees. And so if I choose to design this triangle, or this triangle, or this triangle, it doesn't matter, because in all cases, this is my z here, implying that this is 90, and this is my p, implying that this is my p, and this is going to be my z minus p, and that just needs to be equal to 60, and it's satisfied here if 90 minus p equals 60, so if p equals 30. So it's satisfied if this angle is equal to 30 degrees, right? But you can see the range of you could make this guy 40, and you could choose to design a triangle where this is your zero and this is your pole, and this bro is like 40, and this guy is like, what would it be, 80? Or you could have it so that he's 45 and he is, I don't know, 75. Like just bro, make this 60 and satisfy the condition that 60a plus b plus 60 equals 180. And so a plus b equals 120. And you can pick anything, any a and any b to make this work. It just so happens, like usually it's easiest if you just set one of them to 90 and find out the other person. Okay? Because that means that you can already use the information about your desired pole in regards to your zero or your pole that's going to be located right underneath it, because you already know the distance, you already know the value of that z, because you know the geometry of your SD, you know the real and imaginary parts of your SD. So just make it so that it's 90 as a rule of thumb. This means that we go back over here. We said I need to choose a lead we said I need to choose a z greater than p, right? Because I need 60, so we said we need to choose a lead compensator. And we just decided and we agreed that we're going to go with this format, with this geometry. And this guy's 30, this guy's z, he falls right underneath the SD. SD is minus 1 plus root 3j. Bro. Okay, so he is at, let's just clear this. He's at minus 1, height of root 3. And so I can already tell you off the bat that the z of my lead compensator is going to be minus 1. And the pole can be found by trig, right? So tan 30 equals opposite over adjacent. And so x equals root 3 over tan 30. Tan of 30 is root 3 over root 3 over 3, which is equal to root 3 times 3 over root 3, which is equal to 3. So this guy's 3. The distance between the pole and the 0 is 3. And the 0 is at minus 1, which means that he is at minus 4. So the pole's at minus 4. And so that kind of satisfies it. Now I just have to do s plus 1 over s plus 4. And this is my CFS. And I'm done. But not really. Why? Because there's one final thing, which is the introduction of my compensator should not affect the gain of my system. At least that's what I think we're supposed to think. Right? The introduction shouldn't change anything. And so I have to ask, what is the gain at PC, P of SD, C of SD? Like, what is the surge here after I designed the compensator? What is now the gain of my system at this point? And there should not be a change. So if, for instance, the system had a gain of 2, for instance, right, the system had just a gain of 2. And now all of a sudden, at point SD, because of the compensator added, the system has a gain of 4 at that point. Then I must compensate the point SD by a half to return the system to its original gain of 4. I must not change the gain of the system, right? So I'll find the gain of the system at PSD, CSD, and I'll say that K is going to K times that PSD, CSD should be equal to 1. There should not be a change. And so K is equal to 1 over the gain of the system at PSD, CSD. CSD, PSD, I think I already, PSD we already found over here. We said PSD is equal to 1 over 6. So it's 1 over 6. And CSD, well, I know that SD is minus 1 plus root 3j. So it's going to be equal to minus 1 plus root 3j, so it's root 3j over minus 1 plus 4 plus root 3j. So it's 3 plus 3 root 3 plus 3 root 3j. And just plug this into your calculator, or do the complex conjugates, or just find the magnitude, bro. And that's going to be 3 plus root 3j of equal to 1/2. And you see the magnitude of CSD is equal to 1/2. So it's 1/6 times 1/2, which is, holy shit, this is not good. Oh no, that's not right. That's not right. There's so much that's wrong here. No, what? No, come on. Yes. No. What? Literally no. No. Okay. We'll solve this bug later. For now, let's say that perhaps a better way to do this would be, or to just go about it another way, since, yeah. PS, CS, okay. PSD, CSD, so PSD times CSD is equal to PS times CS, where S equals SD, at point S equals SD. And PS equals to 1 over S plus 1, S plus 4, so PS equals to 1 over S plus 1, S plus 4. And CSD is equal to, CS is equal to S plus 1 over S plus 4. And that cancels with this, and we're left with 1 over S plus 4 all squared. And at SD, which means that S has to be minus 1 plus root 3j, so minus 1 plus root 3j, store that in SD, and 1 over S plus 1, S plus 4 all squared is going to be 1 over 12 minus 6. Oh, so that gives us the same answer as before, which means that my gain k times 1 over 12 has to equal to 1. So k has to equal to 12. The solution, however, does not agree. The solution of this says that the k should be equal to 3. The reason why the solution disagrees is because PSD, CSD in their solution is 1 over S plus 1, S plus 4 times S plus 4 over S plus 1, which gives you 1 over S plus 1 all squared, which gives you 1 over 3. Easy. And so that would make sense in that sense, because you would have k times 1 over 3 equals 1, which means that k equals 3. And for this to be true means that C of S is equal to S plus 4 over S plus 1. And for you to have said S plus 4, S plus 1 means that everything we did was right, except that we just have to switch the poles and the zeros, which means that the poles and the zeros had to be switched, which means that this guy was a pole and this guy was a zero. right? Because if that's the case, then you have pole at s plus 1 and a 0 at s plus 1. Yes, exactly. So working backwards from their solution, suppose 0. So everything we said was right, except for this guy. If he wasn't, actually he wasn't 60, yeah, this guy has to be 60. For me to say that, oh, I need an angle of a pole minus an angle of a 0 to be equal to 60. And this I kind of don't know. I'm not certain, I'm not fully aware of like what the angle rule is, but evidently it's the opposite of what I thought it should have been. Which could be as simple as saying that no, I shouldn't be taking minus 180 plus 120. I should just be saying 180 plus 120. And if I said 180, no, what? No, absolutely not. Like I just need this guy to be 60, bro. Maybe it's minus 180 plus the angle of PST. I honestly don't know this part. But like the solution is the same, but depending on like where you place your pole and where you place your 0, I'm not fully certain where you place your pole and where you place your 0. So we shall figure that out and then do an update or something.